What's the difference between a scalar and a vector quantity? So a scalar is something that has magnitude. Magnitude is going to be the number, or you can think of the value that is associated with it. Now vectors, on the other hand, are something that have both magnitude as well as direction. So what do we mean by this? Let's take a look at an example. So let's say we travel 150 miles. So this is our magnitude. And because there's no direction associated with it, we just call it a scalar quantity. And this would be known as our distance traveled, because we don't know if we're going left, right, or up or down. So it's just our distance that we travel. Now the vector version of this, on the other hand, would be, say, 150 miles, and we define it traveling to the south. So because it has both magnitude, which is the 150 miles, and direction, which is to the south, this would be a vector quantity. And we would call this our displacement in physics. Displacement. Now vectors are usually denoted with an arrow above their variable. So if we take a look at velocity v, for example, we would typically see it denoted like this. So this arrow right here, if you see that, is going to mean that you're dealing with a vector quantity. So let me clear my screen here real quick, and we'll take a look at some examples of scalars and vectors. All right. So some examples of scalars. We can say time, because time doesn't have a direction. So this would be an example of a scalar. Also energy. There's no direction associated with different kinds of energy. And as we went over, distance traveled. This would be a scalar quantity. And temperature as well, because we can't define temperature as having a direction. You can't say like 80 degrees to the east or something like that. Right? So these all have no direction associated with them. Just a value or a number, like time we can define as 60 seconds, or energy as having 100 joules. Like this is just a number with no direction. Now vectors, remember, they have both magnitude, which is a number, and direction associated with them. So an example of this would be force. For example, force of gravity. It has both a value and a direction. Gravity is pulling down on us. And different kinds of forces as well also have both magnitude and direction, such as electric force or the force of a spring. Another example is displacement, as we talked about, being the vector version of the distance traveled, because it has both magnitude and direction. Velocity is another example of a vector, but speed would be a scalar. So speed could be, say, 10 meters per second, whereas velocity would be 10 meters per second to the right or to the left. So we have a sense of direction along with velocity. Lastly, another vector example would be acceleration. So we could define acceleration as having both a magnitude, which is the number, and a direction. All right, thanks for watching.